Welcome to my channel, Conceptual Chemistry Demystified by John HBK. Today, we'll be demystifying IUPAC nomenclature. Let's try out IUPAC nomenclature rules, and we will be applying only for alkanes, alkenes and alkynes. So our learning objective: to understand rules of IUPAC names for straight chain and branched alkenes, that is saturated hydrocarbon. To understand rules of IUPAC names for straight chain and branched alkenes and alkynes, that is unsaturated hydrocarbons. And we'll be able to solve some examples in each type of IUPAC mentioned above. Let's begin. Rules for IUPAC names of straight chain and branched alkanes, that is saturated hydrocarbon. Now, the name of the organic molecule is divided into three segments: prefix, parent or root word, and suffix. Now, the prefix indicates what and where is the substituent attached. It indicates the position and what substituent is attached. Second, the parent or the root word indicates the number of carbon in the longest chain. And third, suffix indicates the position of highest priority functional group present. In this video, we will be learning only with alkanes, alkenes and alkynes. So these functional groups will be covered. For the other functional groups, we will have another video. The parent word used in organic chemistry is listed as follows. For one carbon, the name is meth. For 2 carbon, it is eth. 3 carbon prop, 4 carbon but, 5th carbon pent, 6th hex, 7th hep, 8 oct, 9 non, 10 dec, and so on. The list is given up to 20 carbons. Next, rules. Rule number 1. Select the longest continuous chain of carbon atoms to be called the parent chain, and the other carbon atom not included in this chain constitute substituents. The parent chain is numbered from one end to the other to locate the position of substituent. The numbering is done in that direction that will result in lowest possible local number. Next, the names of the alkyl substituents are added as prefix to the name of the parent alkane. Next, the different alkyl substituents are listed in alphabetical order with each substituent name preceded by the appropriate locant number. The name of the substituent is separated from the locant number by hyphen. When both the numbering gives the same set of locant, that numbering is chosen, which gives smaller locant to the substituent having alphabetical priority. If 2 or more identical substituents are present, the prefix di for 2, tri for 3, tetra for 4, and so on are used before the names of the substituent. For a branched alkyl group having no accepted trivial name is named with the longest continuous chain beginning at the point of the attachment, which is taken to be the first carbon as the base name. Apply those rules to our first example. In this, you see there are 5 carbons in a straight chain, and this makes up your longest carbon chain. And the one which is not included in the chain becomes your substituent. Since it is just one carbon, it is called as a methyl substituent. Now let's start the numbering. Now the numbering can be done from two ends: 1, 2, 3, 4, 5, or from the other terminal end 1, 2, 3, 4, 5. In both the cases, the substituent gets the third carbon, the third position. Therefore, you can go with the either ways. Now let's write the name of the molecule. it is 3 hyphen methyl. The parent contains 5 carbon, therefore pent, and they are carbon-carbon single bond, therefore it will have ane. Just change ane. So this becomes the name of the molecule, 3-methyl pentane. 3-methyl is your suffix, the substituent. Pent indicates the longest carbon chain, the parent or the root word, and ane indicates the carbon-carbon single bond or the functional group. Let's move on to our next example. Now, the molecules look a little more branched, but it is easy. First, identify the longest carbon chain. So, if I see this as the longest carbon chain, I have 1, 2, 3, 4, 5. But wait, there are other ways also. 1, 2, 3, 4, 5, 6. If I go in this direction, from here to here, I have 6 carbons. Also, there is another possibility. 1, 2, 3, 4, 5, 6, 7. So this becomes my longest continuous carbon chain. And those which are not present in it becomes my substituent. So this methyl group and this ethyl group becomes my substituent. Now, where should I start the numbering from? If I start the numbering from here, it will be 1, 2, 3, 4. So let me write down 1, 2, 3, 4, 5, 6 and 7. And if I use the other terminal end to start my number, then my numbering will be 1, 2, 3, 4, 5, 6, 7. If I start from here, the substituents get 4th and 5th number locants, whereas if I start from here, it is from 3rd and 4th. So 3 plus 4 makes up 7 and 4 plus 5 makes up 9. So the sum which gives me less is more preferable. So therefore I will start my numbering from this end. Now this end has 7 carbons. So my root word will be hept. My root word will be hept. What about the substituents? The third position is for methyl and the fourth position is for ethyl. So now I have to write it alphabetically. Which comes first? E comes first. Therefore, I will write 4 dash ethyl dash 3 dash methyl hept, and since this is carbon-carbon single bond, I have ane. 2, 3, 4, 5, 6, 7. So this is your longest carbon chain, and there are 7 carbons. I can have 1, 2, 3, 4, 5, 6, 7. I can go in this direction as well, but it is going to give me the same 7 carbons, so I will prefer this one. If I start the numbering from here, from this end, this substituent gets the 3rd position and this substituent gets the 5th position. And if I start the numbering from here, 1, 2, 3, 4, 5, 6 and 7. Now there is a tie. So this carbon gets the 3rd substituent and this substituent gets the 5th locant number. Now, which is more preferable? there's a tie. In this case, we have to give more priority to alphabetical order. So here the substituent is ethyl, here the substituent is methyl. So E comes first, so ethyl gets the priority, and I will prefer the numbering from this direction. Now the name of the molecule will be, it will be 3-ethyl 5-methyl. 3-ethyl 5-methyl, and the parent contains 7 carbon, therefore it will be hept, and since all carbon are single bond, it is ane. So this is the name of the molecule, 3-ethyl 5-methyl heptane. I hope you understood how I have decided the numbering pattern. Let's identify the longest carbon chain. 1, 2, 3, 4, 5, 6. If I go in the straight chain, I have 6 carbons. Let's see another possibility. 1, 2, 3, 4, 5, 6. So here also I have 6 carbons. So preferably I can go and select this as my longest carbon chain. Now let's put the numbering. I'll start from this terminal end. 1, 2, 3, 4, 5, 6. And if I start from here, this substituents will get least maximum number. So if I start from this end, I am getting 2 to each of the methyl substituents and 4 as a locant number for the ethyl substituent. Now let's write the name. The substituents first. There are 2 methyl groups and 4, and then at the 4th position you have 1 ethyl group. So alphabetically E comes first. So the name of the molecule is 4-ethyl 2,2 dimethyl, and I have parent carbon has 6 members. There are 6 carbons. So it will be hex, and since all carbon single bond, therefore it is ane. So the name of the molecule is 4-ethyl 2,2 dimethyl hexane. Now let's try out for this molecule. Let's identify the longest carbon chain. If I go from this end to this end, yes, this is the longest carbon chain. This can be considered as the longest carbon chain, in which I have 1, 2, 3, 4, 5, 6, 7 carbons in the longest carbon chain. Next, let's see the substituents. If I number it from here, the number would be 3 for this substituent and 6 for this substituent. But if I start the numbering from here, I get 2 for these 2 substituents and 5th position for this substituent. So this is a better terminal position from where I can start my numbering. Now let's identify the substituents. All are methyl group. All are methyl group. So you have 3 methyl groups, but one is at the 2nd position, 2 are at the 2nd position, and 1 is at the 5th position. Therefore, the name of the system, the name of the molecule will be 2, 2, 5. Why I am writing 2 times? Because there are 2 methyl groups which are on the same carbon, 2nd position. So 2, 2, 5 hyphen trimethyl trimethyl, then you have 7 carbons in the main chain. Therefore, you will have hept, and all are carbon-carbon single bond. Therefore, it will be ane. 2,2,5 trimethyl heptane. This is the molecule. Now let's try this molecule. It looks complex, but it is easy. First of all, identify the longest carbon chain. Now the longest carbon chain will be, if I go from this end, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 carbons here. Now this is not a branch. You have to consider this as the longest carbon chain. So from this end I start and I go all the way here. This becomes my longest carbon chain. Now this becomes my substituent, this becomes my another substituent, and this also becomes my another substituent. Now let's do the numbering. If I start the numbering from here, 1, 2, 3, 4, 5, 6, definitely I will give more or higher number to the substituents. But as per rule, we have to go for the lowest possible number. Therefore, I will start the numbering from here, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Now, let's write down the substituents. At the 4th position, I have 2 methyl groups, and at the 5th position, I have a propyl group. So, obviously, M comes first. So, therefore, 4,4 dash hyphen dimethyl hyphen 5 dash propyl. Since you have 3 carbons over here, 3 carbon substituent is propyl, and then you have your carbon main chain which has 10 carbons, so dec, and since these are all carbon-carbon single bond, therefore you will write ane. So the name of the molecule is 4,4-dimethyl 5-propyl decane. So these are the few examples of alkane series. For IUPAC nomenclature, for straight chain and branch chain, alkenes and alkynes, that is unsaturated hydrocarbons. Now the rules are as follows. The longest continuous chain must include carbon-carbon multiple bond. Either it is a double bond or a triple bond, it should include in the longest continuous chain. Second, numbering of this chain must be done such that carbon-carbon multiple bond has the lowest possible locant number. So we are supposed to give lowest possible locant number. The ending ane of alkene is replaced by ene for an alkene and -wine for an alkyne. Position of carbon atom from which multiple bond starts is indicated by smaller locant number of 2 multiple bonded carbon before the ending ene or -wine. Next rule. If the multiple bond is equidistant from both the ends of a selected chain, then carbon atoms are numbered from that end which is nearer to first branching. If the parent chain contains 2 double bonds or 2 triple bonds, then it is named as diene or diene. In all these cases, A of alkane is retained. If the parent chain contains both double and triple bond, then carbon atoms are numbered from that end where multiple bond is nearer. Each systems are named by putting ene ending first followed by -wine. If there is a tie between a double bond and a triple bond, the double bond gets the lower number. Now let's solve some example. Okay, now let's see some examples and apply those rules to the examples. Now we have a skeleton chain of 4 carbon atoms having a double bond between first carbon and second carbon. So since the parent chain has 4 carbon, the parent root word will be but, and it has a double bond between first carbon and second carbon. We have to give the least possible number of the two. So 1 is the least. So the name of the molecule will be but and hyphen 1 dash ene. So ane is replaced by ene, and this is your but 1 ene. In the second example, again you have 4 carbons and the double bond is now between second and third carbon. So the name of the molecule will be but hyphen 2 hyphen ene. So you have to select the less number, you have to select the least number of the two. In the next example, you again have 4 carbon as the longest carbon chain or the parent chain, but you have the double bond between first and second and third and fourth carbon. Therefore, the name of the molecule will be but dash 1 comma 3 dash diene. So we are putting diene because there are two double bonds and one is between first and second carbon and the other is between third and fourth carbon. Let's move on to our next example. Yeah, we have a simple longest carbon chain and let's apply the number. Definitely we will give the least possible number to the carbon-carbon double bond. Therefore the numbering will be from this end 1, 2, 3, 4, 5. 5 carbons, and therefore the name of the molecule will be pent hyphen dash 1 ene. So it is pent 1 ene. In the next example, the numbering is already done 1, 2, 3, 4, 5, 6. 6 carbon. Now here you see that this is your substituent, this is another substituent, and this is your third substituent. All three are methyl groups. Now why we did not start the numbering from here, this end? Because we have to give the least possible number to the carbon-carbon double bonds, because that is given more priority compared to the alkyl groups. Therefore the numbering starts from here 1, 2, 3, 4, 5, 6. Now let's write the substituents. There are 3 methyl groups. One is on the second position, the other are on 5th position. So 2, 5, 5 hyphen trimethyl, and there are 6 carbon atoms in the main chain. Therefore it is hex, and this is a carbon-carbon double bond between second and third carbon. Therefore it will be hyphen 2 hyphen ene. So the name of the molecule is 2, 5, 5 trimethyl hex hyphen 2, 2 hyphen ene. So that is the name of the molecule. Now let's see the next example. In the next example, if you see, this could be the longest carbon chain, but when you select this as your longest carbon chain, the carbon-carbon double bond is not included. But as per IUPAC rules, you have to give the priority to carbon-carbon double bond and the triple bond. So they should be included in the longest carbon chain. So therefore I select this as the longest carbon chain, which has 5 carbons. In the second position you have the 3 carbon substituent, that is your propyl. So the name of the molecule will be 2 hyphen propyl pent hyphen 1 dash ene. So this is the name of the molecule, 2-propyl pent 1-ene. Now let's see some another examples. Now this is carbon-carbon triple bond over here. So the least possible number will start from this end. 1, 2, 3, 4, 5. So the name of the molecule will be pent hyphen 2-wine, since it is a carbon-carbon triple bond. So that's why we put wine. Now over here there's a double bond as well as triple bond. So more preference is given to carbon-carbon double bond. So here 1, 2, 3, 4, 5. So there are 5 carbons in the parent chain. The second is the substituent. Therefore, this is your substituent, methyl group. So the name of the molecule is 2-methyl. Parent chain contains 5 carbon, therefore pent hyphen. The first double bond is between first and second carbon, therefore 1-ene, and 3 and 4th has carbon-carbon triple bond, therefore it will be 3-wine. So this becomes the name of the molecule. In our next example, again carbon-carbon double bond is given more preference. 1, 2, 3, 4, 5, 6. So the name of the molecule is, and you have one substituent over here at the 4th carbon. So the name of the molecule is 4-methyl 4-methyl hex hyphen 1-ene hyphen 5-wine. So this is the name of the molecule. I hope you understood. Through this few examples, you need to practice. Thank you all. I hope you understood. Please don't forget to like, share and subscribe to my channel. Bye.